I'm just I'm gonna send the code in that chat.
You can demonstrate code and explain what did you do.
Yeah, sure. I'm gonna send it on the chat, actually, the chat of this room.
Uh-huh.
Oh, I can send more than 200, 122 pages. Okay, I will share my screen, I suppose. Can we do it? Mm-hmm. Take this one here. Can you see it? Okay. What happens?
Uh,
No, that's I will just check.
yes, I think yes.
Oh, okay. So can you see me moving the code going down and going up?
1 second. I set up OBS, which is
Okay. How can I stop this? I don't know. I just don't understand what's going on.
mhm. um, you have ended your stream.
Yeah, just a second. I'm trying to do something because it was not.
Mhm.
Okay, I'm gonna send my code actually in two ways. I will divide the code to two separate parts because it's not sharing the screen for some internet problems.
Mhm.
Hold on. So messages. That's the first part, and the second part is so yeah. So I think I'm ready. It's in the code actually in two parts. It's a little bit not obvious with the integer main, but anyway. Should I start?
Yes, you can start, but did you send your code to the general chat
Yeah.
in Discord?
No, not to the general. I send it to this room. Комната для учебы.
Okay. Uh-huh. I see.
Uh-huh. So basically, what I did is my problem is called the fractional knapsack, which is we have items with weights and values,
Mhm.
and it's similar to the problem that it's called the 0-1 knapsack, where you take one item or you don't take any item. And the problem with 1001 knapsack, we can't solve it in a greedy algorithm because we can take a fraction of an item. So either we take an item, full item, or we don't take anything. And that's why we can't use a greedy algorithm. By greedy algorithm, I mean when we take the profits of the items, like when we take values over weights of each item, and then we sort them from like the very profitable item, and then we start putting from the most profitable item to the less profitable item. So Uh, and
Ah,
but
okay.
we
Why is this task is not NP?
not what
Not NP hard.
not hard because it can take a green solution like doesn't require DP.
Uh, okay, you came up, you come up with an algorithm that works for poly n. That's why this algorithm is. That's why this task is polynomial. Is p task.
It's bad.
Ну, P есть, we have
Ah,
tasks NP hard, NP, NP, and so on. So this task is P because you come up with algorithm that greedy, and so you can continue.
okay. Um, so the thing here, what I did is the same idea of taking actually profits, which is taking the values over the weight. But with the we can do one more thing here in the fractional problem that we can take a fraction out of like we can take a fractional weight. We don't have to take all the weight. So in this case, that's why it works here and doesn't work in 0, 1 knapsack, but it works in fractional knapsack. That's why it's more efficient to do it. So what did I do? Basically, I have an integer max capacity, which is the capacity of the knapsack, and the size here is yeah, the size is the size of number of items basically. I created two array. I look at new two arrays. One of them contains the value, and the other contains the weights. And this is just to enter the weights and the values. After that, I made two functions. We have a function bool compare that will we use when we sort because I mean I could use another way of sorting, but I used std sort basically here in this task. But we can use like more efficient methods. But I just did it to simplify the tasks, not to enter into so many ways of sorting. Um, the function is float because it will return a value. It might be float because we are taking a fraction of a value. So this value might be like 0.3, 0.4, or something like this. So we may have like a value of 50.3, for example. Uh, we will pass arrays, the arrays of values and weights and max capacity and the size. I defined the total value, zero, which start from zero. This value will be inside the knapsack every time we add. I defined, I declared a vector bear because we need to take the ratio. This vector will contain floats, the ratio of values over weights, and it should take an assigned long long by taking basically the how to say it, the index because when we take the values or the values over the weights for each item and then we sort them if we keep the same indices that we had before that will change we can't I mean we need to relate each after sorting each value we got to the weight and the value that we had before, so that's why we need to make pair. I mean we could use hash tables, but I think it's much better to use vector pair. um, then we just make the pairs of arrays values over arrays weight because we need to take the ratio of them and with index I for each of them so it can relate to the values and the weights before. Then I sort them std sort using std sort from the beginning to the end and using the function compare because this function will sort them in ascending order, in descending order from like not increasing order, just decreasing order, because uh, because we will start taking from the biggest value to the last value. And then we have a loop that's starting from zero, which is smaller than the number of items. And first we have a checker if the max capacity, a condition if max capacity is equal to zero, we break. I mean, basically, if we passed, let's say that the knapsack is zero, for example. So it will just break the loop. And in another case, when we are continue adding the values, In case we reach that the max capacity, I mean the capacity of the knapsack is zero, so we will break, so not continue the loop. So that's why we need this condition at the beginning. Then we get the current index by taking that current index is equal ratio I second, because that will give uh like for the item that related to the profits over the weight, the index of it. So when we access the profits of weights of the first one after sorting, it will relate it to the idle weights and values, even if it was like the third value, for example. So that's why we need the current index. And now we have a condition that if array weights of current index is smaller or equal than the capacity, then we just take the item by itself by taking that, and we subtract from the max capacity the capacity of, or the weight of the item, and we add the value of item. We take the like I mean, if we have enough capacity to take a full item, so we take just the full item and we take the full value. Total value will be added to the value of the item. Other ways that if we arrive to a value after sorting, of course, if we arrive to an item when this item has a weight greater than the capacity that we have left, so we need to take a fraction out of this. We need to take a fraction out of this item. So to do this, we basically need to take uh, max capacity over the weight of the item, and we'll multiply by the value of the item, and that will give us the value of the fractional value after taking like the fractional capacity basically. And just a second. Yep. Oh, yeah, that's it. So, and then we add just total value to the fractional value that we get, and we set the max capacity to be equal to zero in this case, because since we have an item, I mean, since the capacity now is like it can take a full item, it took a fraction. It means that it's equal to zero, so we set it equal to zero, and that will basically break the loop if it was not the end of the loop. And then we just return the total values. And I deleted the arrays, and that's all.
Mm, okay. I thought you can um, use сейчас you сейчас как это называется? Okay, I'll send you later what I mean. Who is the next? Who will be next? Or
I can.
mhm.
1 second. I'll drop my code to the chat. Is it okay?
Сейчас. Where to?
I send it to общее.
Uh-huh. It's okay.
Okay, so my task is time dependent. Knapsack problem this is like the normal one, but with a time limit. Uh, so the first, I create a three-dimensional table to store maximum value of each time, weight, and item combination. Like this, and after that, I just go through the elements, time and capacity. Um, I iterate through each element from the first um, to the last. Then each time sort from one to the time horizon, and each time we should sort out each capacity from one to capacity of the backpack. Um, After that, I just calculate the maximum value um, for each combination of time, um, weight, and item. We should compare the previous maximum value of time uh, with power, um, with weight, and item with two different possibilities. The first one and the second. The first one, we should check if the current item weight is less than or equal than the current capacity, um, and the remaining time is greater or equal um, than the time limit. So we just add the value of the current element to the maximum value taken by um, two remaining things. It's capacity and time for the previous element. And in else, we just eliminate current element by setting maximum value at the current time, capacity and index of the element equal to maximum value from the previous element, and we just return the maximum value at a given time, capacity, and element index.
Okay, please explain why did you take to your maximum second argument memo minus one t
Mhm,
minus time e w minus weight e
mhm.
plus value e. Why did you take to your capacity this?
Um,
You consider
mhm.
what just what opportunity did you consider? You the case you consider uh, when you
When the weight is less, I mean, when the current item's weight is less than equal than current capacity, and time limit is greater or equal than current time limit.
um, I mean you take to your maximum
Mhm.
two
Two
values.
two values, yes.
Why did you take the second value? Because no, describe the case. you just you just take some dp with arguments e and take value plus e. And what the case was? You consider, okay. Did you understand my question?
Yes, I understand, but like in this situation, I'm not quite sure why we take this.
I I didn't understand why you in the second argument of memo
Mhm.
uh, you take
Why we taking this maximum
t
of
minus time e. You take memo e
mhm.
minus 1, t minus time e, and w means weight e. Why did you take t minus time e? Because did you consider somehow
uh,
the
in
time?
like
Uh, okay, okay. I I think I understood. Okay, you can continue. Uh,
um,
so so you return memo num items time
num items,
horizons.
time horizon, and capacity,
Uh-huh.
and like this is in main. I consider um, some example with capacity 10 and time horizon 5. I can show what. Did you see my screen?
No.
No? Oh, I forgot to. Sorry, 1 second. Sorry. I can demonstrate what will be in this example. When we have capacity 10, time horizon 5, like some, for example, like we have these values. Um, we get that maximal value what we have is like 13 in this example. So it should work.
Mm-hmm. I think it worked. It works because we consider uh, almost the same tasks, the same task, but without time e,
Hmm.
but without time, and it will be work. It obvious because we consider in this example we consider we just iterate through time, and this will be the same. Just this idea was the same with the previous task.
With the default one, like we just add
Uh-huh.
one more parameter.
Yes, yes, yes.
Mhm.
Okay. So who will be next? And Shub, Ritupar, Tim.
Yes, I'm here.
My tablet is my graphic tablet is broken because I think it's it will be better if you uh, tell us your solutions.
I have also my solution. Can I explain?
uh, okay, you can, but
Okay, okay. Okay.
you can.
Should I send the code in the chat?
You yes, you should.
Just 1 second. Okay, sorry for the background noise. I'm in the street, but anyway. So the problem equal sum is about checking the possibility of splitting an array into two subarrays where the sums of their elements are equal. For example, let's say we have an array 4, 6, and 10. We can split this array into two arrays with elements 4 and 6 in one of the subarrays and 10 in the other subarray because both of them sum up to 10. And so there are many methods we
Could
can use.
you once again? Could you
Yeah,
tell? Could, did you hear? Could you tell the task, not the solution? I forgot. and
the task is equal sums partitioning.
okay. So okay, you can tell solution.
Yeah, so if we want to solve it by dynamic programming, we can create a Boolean function. And in this Boolean function, we will create a 2D array. So we take an input, the array, the original one, int array, and we take also the length of the array. And then we just create a variable 0 sum and two counters. First of all, we calculate the sum of the elements of the array. And the first condition we have to check is if the sum of the elements is odd. If the sum of the elements is odd, then we definitely can split the array into two subarrays with equal sum. So then we return false, sorry. And then we create a Boolean 2D array where the part, like where the temporary, I'm calling it temporary, uh, the temporary array will represents whether it's possible to form a subset of some I in the first dimension and j using the first j elements of the array. So let me just send the message to make it clear. So temp I j yeah. So uh, I is the sum I. So we want to create a Boolean 2D array where I is the sum and j are the elements of the array. Is it clear? I'm not sure. I think no. So the temporary array with the index I and j mean that if it's possible to form a subset of some I using the first j elements. Yeah, okay, that makes more sense, I think. And then after that, we can just fill the first row with true because we can create. It's always possible to form a subset with a sum of 0. It's just choosing no elements. And we fill the first column with false because you can't form any sum with an empty subset. So, and then we start with the bottom-up approach, where for each element we have to consider two possibilities: if we include it in the sum or we don't. And therefore we have double for loops. And in these for loops, in the first one we loop from the second element, like from the second row, because the first one is 0, from the second row up to the length of the first dimension. And the second for loop, we loop from the second column to the number of elements, which is n. And in each one we basically assign the value of the current cell to the previous one on each row. So we're switching columns, basically, like flipping the columns. And if the sum is bigger than the previous sum, then we assign the current cell to the one either. Here where we're checking the possibility of including or excluding. So temp ij excuse me. So here we're checking if the sum is bigger than the sum that we have, we don't want it. But if it's not, we go inside the if else, and then we either keep it the same if we can include it, if the element is includable, and if it's not, we just assign it I minus. So basically, the sum minus the previous sum, and on the columns we assign it the previous element, j minus 1. So we are excluding the element because it's j minus 1. J represents the number of elements that we are including. And then at the end of this function, we return the cell at the end, which is sum over 2, row sum over 2, and column n. And basically, this is all of the function. And then we have the driver code where we are just like testing this function.
Okay, I see. It's very clear. Mm, okay, I have any questions. So, so Ritupar, you send me the PDF.
Yes, the whole explanation that I'll use.
Uh-huh.
Mhm.
Okay. Uh, could you explain this the demonstrate on the demonstration or
You're talking to me or Tim?
Ritupar?
Uh-huh. Okay, wait, let's see. Can you see it?
I see.
Mm-hmm. Check. Yep. So we are given an array of non-negative integers, and we are given a sum, target sum, and we need to tell if there exists a subset in this given array whose sum is equal to the sum. For example, here is the array 3, 34, 4, 12, 3, 2, and we want the sum 2. So our function should, or our program should return the boolean value true, because there is a subset 3 and 4 which is total of our target sum, which we need 7. And same way here, we have the array 2, 2, 2, 3, 2, 2, and the sum is 10. So we can see there is a subset in our given array whose sum is total to 10. And we can solve it by recursion, but I'll explain by dynamic programming, because if we do by recursion, then the time complexity will be 2 raised to the power n, because it will take all the subset of a given set. So it's not really what we want. And while using dynamic programming, we are including the header file, then writing normal class, subset, and the function that will initialize our normal subset, which is past this vector int, which is the set, which is the vector of our numbers, which we want to analyze if it contains a subset or not. And then this is the constructor which initializes with the input of the set. Now we are uh, setting the size, and we are resizing it to create a 2D vector which like in knapsack we do n plus 1 and like number plus 1 and weight plus 1. So here we are doing same, the number of the size of the array plus 1, and the second dimension is the sum, which the sum we want plus 1. And this is the function, the Boolean function, which returns if the subset if our set contains the subset which totals to our target sum or not. Basically, the loop, which, for example, the outer loop corresponds to the rows, and the inner loop corresponds goes through the column, and then we check and we return if our subset has a target sum or not, which the logic is explained here. For example, if we were if we consider it using our knapsack, like if we compare it to our knapsack, then in knapsack we used to have our item array and two properties of it. For example, weight and value. Here it's in knapsack we had the choice whether to put it in the knapsack, the element, or not. And here we have the same, whether to put it in the subset array or not. If our set is if our sum is total to the target sum. So we, for example, here 2, 3, 7, 8, 10. The size of the array is 5. So we initialize our initial array size plus 1, which is 6. The sum we want is 11, so we initialize sum plus 1. So our initialized array is having dimension of 6 and 12 to the array. And for example, if we explain it using this table, then in the first element where is 0, so we want an empty set, and to get an empty set we can choose, like we can use the sum like 4 or 5, and if you add 4 or 5 empty set, it will be an empty set. That's why it's true, and for rest of the value it's false. And now if we want for example, if we want 11 and our set has 2, 3, 8, and we have two options: either we can choose 8 or we don't choose 8. So we use this logic and decide if we should choose 8 or we should not choose 8. But for example, if we go through 5, then 5 is less than 8. We cannot make it if our sum is 5 and we are 8, so we cannot get 5 from 8. So for example, like here, if our sum is 0 and we are already at 1, so we cannot get 0, so the rest of it is false. That's how we initialize the set and uh, return the value if it's true or false, if our set has a subset or not.
Okay, it's similar to team solution, similar idea.
Yeah,
And so,
is the subset sum, yep.
we can have a break for
Mhm.
5 minutes, I think. Okay, let's continue. I try to write on the board. So we consider in the previous semester we consider some idea that if we have some we can just if we have some subset of chars, we can if we have subset of chars, we can represent them like bits. It will be, for example, it will be this 26. So in this part we in this lecture we consider the more general idea. If we have some, let me write like text. Yes, I don't have tablet, graphic tablet. So if we have some set and we just consider some set of the set uh, a1 and so on ak we consider subset. Then we can represent it like bits b1 b so on bn, this is sequence of bits where by e it's 1 if e belongs to a1 and no if else. So it's we have unambiguously corresponding between the subsets of the A and what and sequence of the bits. So for example, if we have a2 like 1 3, it can be represented like unambiguously corresponds to 1 1 and so on, no, and so on. N n okay. So we can store this sequence we can store in int. How? If we have some for example 1 so on, this corresponds this basic response to what? To просто equal to 1 2 to the power of null plus 2 to the power of 1 1 plus 2 to the power of 2. It's very obvious, and so on. So it equals to like 6. Okay, we can uh, store this number in bits if n less or equal than 32. 32. Yes. So um, we have operations on these bits. We have bitwise operations. Так. So so I can tackle it. Okay. First operation is bit extraction. We just want to extract element. I mean element presence check. Just check exist or not exist our element. So pseudo code will be like this. We just what will we do? We just on input we have mask and position when we want to take bit, and just returns what? We just return masks, and we shift our mask in both elements and compare it, take a AND operation. That's the obvious thing. And second, we want to consider, we want to take union of our sets or take intersection on difference. So it can be present. It can be easily. We can easily take union in bitwise operations too. So AUB, how to take union of A in B. We just consider mask A. We have mask A and mask B. And what we will do next? We just take ED or operation if we want to consider union. How to take union? How to take intersection? It's obvious. Okay, and how to take difference? A little bit harder. A little bit harder, but if you mathematics logic, if you have mathematics logic, you like difference can be calculated use union and an XOR operation. XOR, so it will be just mask A or mask B, and we just take XOR XOR of mask B. All operations will be calculated, or complexity of all the operations. Complexity of all the operations is all 1. It's obvious, I think, because we just we have bits, and we just take on in processor can calculate this these operations in one tact. It's very it's very easy to calculate for processor. So okay, consider the tasks. We have some construction. So consider task. Do you know what is Hamilton way? Hamilton pass. Hamiltonian pass. Меня не слышно? Okay, you don't know what is Hamiltonian pass. So first of all, what is Hamilton pass? Hamiltonian pass. It's a pass. Pass in нет, Hamiltonian pass in G, in graph G. What is this? It's a pass where that passes all verticals in graph G. So, for example, if you don't know what is Hamilton pass, we consider some graph. And Hamilton pass of this graph will be it'll look like this. We visited all the values, all the verticals, and this is a pass, not just walk. So there is a task about Hamilton pass. I think I can turn on demonstration. So there is a task. We need to find, we just need, given a complete weighted graph, unoriented or oriented, it's no matter, graph. And we need to find what? We need to find just Hamilton pass. Hamiltonian pass. The cheapest, because this graph is weighted. So how do we we will use bitwise operations in this solution, and this solution is NP hard problem. This task is NP hard problem. So so it's it's clear to that we want to iterate through all the subsets of this graph, and we get complexity 2 to the power of n, O2 to the power of n, and so in this task can be solved by the method, which is we consider some paths. We consider some paths, this Hamiltonian path. We visited the values, the verticals, and what information do we need to continue this path? Just numbers, the numbers of these verticals we need to know, and the last and number is and the number of this vertical. So we can represent our graph, our verticals, in bits, into bits, and we consider last vertical of this path, of the Hamilton path, and we consider what? We consider mask. Mask, блин, лучше так писать. We consider, блин, 1 second. I turn off demonstration because у меня лагает. One second. So we consider some path, and we need to know last vertical and mask. Mask. What is mask? We consider subsets, and subsets will be subgraphs of our graphs. Wait, not subgraph. Some subsets of set of vertical set, and so in the pair we just store minimal total weight of the visited verticals represented by the mask, and the last, the in which Hamilton pass end ends in web. Okay, the base. What's the base? If we take minimal, okay, let's давайте fill our dp with plus infinity. std numeric limit of int if we have only 32 verticals or unsigned long if we have just long if we have more than 64 verticals, less than 64 verticals, and with this max. So this will be this, and the p of if we consider after this we consider our vertical. It's not the p. It's just it's previous step, because we consider, if we consider minimal, then we just fill our array with maximum. That's in the all the task, I think. And we just, if we locate it in vertical way, mask of only this vertical will be 2 to the power of v. It means mask contains stores only vertical way, and we just fill it with null, because because Hamilton, because we don't store any edges. Step will be what? If we consider some dp ij, dp not ij, v and mask. So this task can be easily solved by forward dp method. If I remind you that in forward dp we trying to push information to the next cal of dp. How do we? What if we have dp v mask? We consider some vertical. We consider some vertical where, and we consider some mask. Also sphere, просто mask, just mask. That we in mask we have already know the pass, the Hamilton pass, and we consider some verticals that are connected with our where. So we trying to push information to push the answer to these verticals. And how do we want to push it? we iterate through these verticals. It means consider all the verticals and just consider some consider if we didn't visit that these verticals, we just continue to do what? We continue to calculate answer. So visited can be this function visited. Сейчас типа написать здесь. This function visited is bit extract. Just bit extract e. So if we didn't visit this vertical, we just consider the pair u and new mask. New mask will be what? We consider we include this vertical in our mask. That means we just take mask and one u. We just shift the bit through u and we get new mask. So we consider new mask. And how do we get it? Our Hamilton path like minimum of if we when we push information we to this vertical, it's not not the first information that we pushed. It can be so we take minimum of the PU new mask because we can consider this vertical before, and we push what the P mask, the PU new mask, or new mask, mask, and plus it to cost VU, where U is vertical, U. I think it's obvious. So we have step how we calculate new dp, and we so the step will be this, and this is what order will be like what, how we calculate through our dp. We just iterate through all the verticals through all the mask. n minus 1. We then we iterate through what? Through all the we iterate through all the mask, then we iterate through all the verticals for mask, for verticals, e to n minus 1 and no now n minus 1, and we get the answer. Because if we need to know only if we have some mask, if we have some mask, we just need to know we just need to know embedded all the embedded sets of this mask. It means if we have some mask, we just consider if we have some bits, we consider all the bits. It means which is which. If we just ended it, what is embedded? Embedded is how we no embedded in our what u in our mask. Consider this only this verticals. Embedded means embedded means what? We just take end and check if it equals to b0, so on bn minus 1. It's embedded. So we just iterate. We can iterate through in this order and get the answer. Do you have questions? Okay, complexity. No, complexity is obvious. Complexity is all to the power of n on n multiplied by n squared, because we consider we just get order, then we get step, base and step. On step we have another cycle, and memory. Ой, что? And memory will be just all two. We can in the previous lectures and seminars we consider idea that we can in this order. When we have this order, we can reduce one cycle and we can reduce all the rows that didn't consider, that we don't consider. So that was the task. Have we do we have a minutes? Okay, we have, we did. Okay, I think we can't consider the next task because I give you exercise. I think exercise check check is there is Hamiltonian pass, but graphs is incomplete. How do we check it? Hint for you. It can be done. Сейчас как бы написать-то? Set of the functions will be more than on all. Just n. This task will be can be solved like some key. Okay, and I give you two points for this task. Who will be the first? Okay, why can I consider some task? Okay, I give you definition. In the next lecture, we consider the pawn profiles and one task on the Bitmasks, and we will end with the pair. And so in the next task we consider click. Do you know what is click in graph? I didn't know.
No, I don't know.
Okay. Let me explain by visually. If you consider some graph, сейчас как-нибудь такой. You consider some graph. So, what you consider some graph. Click in this graph will be this, 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 and this. Only one vertical. Maximum click of this graph will be the star graph. Complete star graph. Complete graph is 5 verticals. Okay, I think more formally, what is click in graph? This maximal, what? count of what of verticals of verticals. Записать там. Have some graph. Блин. Окей. Так. Of verticals. In this vertical, if we consider some verticals of subgraph of graph, we can we consider some verticals, and so if there's h between these verticals in undirected graph G, так, E of the V. Так, да? So this is the definition. We consider all the graphs, and if there is an edge, there's if we have complete graph, subgraph, we just we just get maximum vn. V is что как написать? Вот так. Size of v, if v is v1 и just сюда добавляется такое условие v1 равно n equals to n. Okay. This is the click. The maximum click. For this graph G. Do you understand? What? And so, so that's all. I think in the next seminar we consider task on click. So goodbye.